Hello, in this video we are going to look at integral calculus and some economic applications by taking the integral of various marginal revenue functions to get back the firm's total revenue function. If you need more background on integrals and the rules of integrals, you should see my first video that reviews the basic rules of integrals and applies those rules to marginal cost functions. So, example 1, we're going to have a firm that has a marginal revenue constant at $100, so marginal revenue equals 100. We want to find the firm's total revenue function. One thing I note here is that the derivative of total revenue is marginal revenue. The process of integration is just the opposite. It can be viewed as the antiderivative. So the antiderivative, or the integral of marginal revenue, will get back to us the original function, which is total revenue. So using our integral notation, the integral of 100 is just going to equal 100q plus a constant. And I note here, and again I review this in more detail in my other video, the rule of integral of a constant is just going to be that constant times a variable. X, or in our case, our variable here is not x, it's q. So we get back 100q plus a constant. So therefore, total revenue equals 100q plus a constant, but we know something about total revenue. That is, when q equals 0, total revenue equals 0. So that implies that the constant is 0, and I will no longer be writing it. So total revenue just equals 100q. We can check our answer. If we take the derivative of total revenue, we will get back marginal revenue. So the derivative of 100q is just 100. And just kind of one other final thing, if you wanted to get back the price or inverse demand equation, you could take your total revenue equation and divide it by q. That's price or average revenue. So price equals average revenue, which just equals your total revenue divided by q. So in this case, price equals 100. So we're really dealing with a perfectly competitive firm in this example. A perfectly competitive firm is a price taker, takes the price as a given, and that price will also equal marginal revenue. All right, let's do a slightly more complicated example. In this example, a firm has marginal revenue given by 50 minus q. Here again, we want to find total revenue. So writing this in integral notation, using our integral notation, we're going to take the integral of 50 minus q. We can use the rules of sums and differences to break this down into two functions. So we're going to take the integral of 50 and subtract from that the integral of q. And we're going to use some of our rules down here. Once again, the integral of a constant, in this case 50, is going to be that constant times a variable. So 50q is the integral of 50. And then we're going to subtract out the integral of q. And here's a new rule. We're going to look at the integral of a power function. We're going to follow this rule. So if we want to get the integral of x raised to the power of n, we're going to follow this format right here. Whatever x is raised to, we're going to put down here in the denominator and add 1 to it. And then again, whatever x is raised to, we're going to add 1 to it in the exponent here. So in our case, q is just raised to the power of 1. So it's n plus 1, where again, q is just raised to the power of 1. So it's 1 plus 1. And then following the rule, it's going to be n plus 1. What is n? Again, in our case, q is just raised to the power of 1, so it's 1 plus 1. Now simplifying all of that, 1 divided by 2 is just 1/2. Q raised to 1 plus 1 is just going to be q squared. And here again, following the thing I mentioned on the previous slide, at q equals 0, total revenue equals 0, so we can just ignore the constant now. So total revenue will be given by 50q minus 1/2 q squared. If we wanted to recover the price equation, we can get average revenue. And in this case, taking total revenue dividing by quantity, we get the firm's inverse demand or price equation. All right, let's do maybe a slightly more complicated problem. If marginal revenue equals 50 divided by the square root of q, or we can rewrite it this way, 50 equals q raised to the minus 1/2 power. Let's go ahead and find total revenue. So the integral of 50 multiplied by q raised to the minus 1/2 power. We can bring the 50 out in front here, and then just take the integral of q raised to the minus 1/2 power. We're going to use the integral of the power function rule. So in this case, n is minus 1/2. So we got minus 1/2 here for n plus 1. And then we're going to take q and raise it to the n power plus 1. So n is again minus 1/2 plus 1. Simplifying all of that, 1 divided by 1/2 is just 2. And minus 1/2 plus 1 leaves us with 1/2 here in the power. So simplifying, we get total revenue of 100 times the square root of q plus a constant. And like I said before, when q is 0, the total revenue is 0, so the constant is 0, so not writing that. We get a total revenue given by this equation. If we wanted to recover the inverse demand or price equation, just divide total revenue by q, and you'd get 100 divided by the square root of q. All right, I hope you found this video helpful.